In this next section, we're going to use the Pythagorean theorem to determine if a triangle is an acute, obtuse, or right triangle. When you look at a triangle, let's just do this visually first. Triangle with a right angle is a right triangle. Acute is where the biggest angle is actually less than 90 degrees. So all angles are less than 90, less than 90. All angles less than 90. And then obtuse would look more like this, where one angle more than 90, greater than 90. One angle is more than 90 degrees. What we're going to find, if you look at these not amazing pictures I drew, is that if these two sides are the right length in the Pythagorean theorem such that it does in fact a squared plus b squared equals c squared, then you know you must have a right triangle. In the same way that if you have a right triangle, you can use it to calculate the sides. What happens is if you take your two shorter sides and square them each, add them together, and try to make it your longer side, and the long side is not long enough, so this side that you thought was going to be your hypotenuse is too short, then you must have an acute triangle because that side is too short. It's pulling the angle in closer together. And if you look at this picture down here, this last side is too long to be a right triangle. If that's going to be too long, then you must have an obtuse triangle. So when the extra side is too long, it's obtuse. I think this is easier to understand by example, so let's do it. We have A, B, and C in what looks to be a right triangle. Let's try it out. A squared is going to be 10 squared plus we have b squared, so I'm going to put parentheses around this because otherwise it's likely to get sketchy. 10 square root 2, all of the pieces in that are being squared, equals c squared equals 15 squared. 10 squared is 100. 10 square root 2 squared. 10 times 10 is 100. I'm going to do this over on the side, times the square root of 2, which is squared, which is just regular 2. Square root of 2 times square root of 2 is square root of 4. Square root of 4 is 2. Lots of ways to think about how to do that problem, but you end up with 100 times 2, which is 200. You could also type that in your calculator and then hit the squared button, and if you type it in all correctly, it would come out to 200. And we think it equals 225. Sometimes when these are written out in textbooks, you'll see a question mark above the equal sign because we're not sure if it equals 225. Or some people might just leave that area blank for now, since we're not sure what's going to happen. Well, 100 plus 200 is 300, which means that the hypotenuse, this side here, when the square is only 225, less than the 300 that we expected, this side is too short. So if you can imagine this picture looking more like this, if that were to happen, this triangle would look more like that. So if that side is too short, it sucks in the other side, making this less than a right triangle. It is an acute triangle. Same logic applies to every one of these. If the hypotenuse side, so this is the hypotenuse side or the c squared side, I'll put c squared. If that is too small, like it was in this problem, you have an acute triangle. If this side is too big, then you have an obtuse triangle, because that would make that too long for a right triangle as an obtuse triangle. And if they're exactly equal, if it's just right, then you've got Goldilocks, or a right triangle. So moving on to the bottom, it's the same principle, just without pictures. The one nice thing about these pictures is it makes it clear that's the longest side. That's the longest side. Down here, what's the longest side? Is square root of 199 the biggest side, or is it actually 17? It's hard to tell. What I recommend doing, since you're going to have to square them all anyways, is squaring every one of them and then seeing what your longest side is. So if I take this square root of 26 and square it, it's 26. Pretty straightforward. The square root of 199, if I square that, well, square root squared, 199. 17 squared, well, that I need a calculator for because I don't, it's going to be 17 times 17. 289. Ooh. So that one is actually my biggest side. This one right here is my biggest side. So I'm going to take the two shorter sides, 26 plus 199. Remember, I already squared these, so I don't need to do that again. And I'm going to see how that compares to 289. Well, when I add those up, I get 225 over here. And I have 289 over here, meaning this side here is too long. So if you imagine that supposed right triangle, but this side is too long, meaning that that's going to stretch out this picture, making this angle too big or obtuse. Again, same thing applies to all these. You're going to want to square each of them. The longest side is going to be your potential hypotenuse. Take your two short sides, add them up. If the supposed hypotenuse is too big, then it's obtuse. Too small, it's acute. Just right, it's a right triangle. Good luck.